Electronegativity has trends that are kind of the opposite of what we see with the radius of the element. And so electronegativity is just the measure of how easily an element can attract another element's electrons. Okay, so what we'll see is that down here, the green is going to be a lower electronegativity compared to over here where we have the bright pink. This is going to be a higher electronegativity. So these atoms over here are better at attracting electrons from other atoms than ones over here. Okay, and so this does kind of have to do with some of the things that we talked about when talking about the atomic radii. Okay, so down here, it has the most energy levels. It has the greatest atomic radius. And so the electrons from other atoms are going to be pretty far away from the nucleus of this atom. Okay, so it's not as attracted. So the fewer the energy levels, they're going to be easier to attract. Okay, so here, this one only has 2 energy levels, so it's in period 2. It has the electronegativity of 0.96 compared to this one down here that has 7 energy levels. It only has electronegativity of 0.7. Okay, so as we move up the periodic table, they're able to attract the electrons more just because the atomic radius is smaller because there's less energy levels. Okay. Also, the electronegativity is going to increase from left to right because the larger nucleus with more protons, more of that positive charge, it's creating, once again, a smaller radius so that the electrons from other atoms can be more attracted to, let's say, fluorine than they would lithium, okay, because that atomic radius is smaller. All right. Notice here in the middle that there's kind of a strange pattern. It doesn't kind of fit with the rest. So transition metals, they show very little difference in electronegativity. Okay, so we kind of ignore the transition metals whenever we're kind of predicting the electronegativity of different elements. And then also noble gases. We generally don't talk about them when it comes to electronegativity just because their outer shell is already full, so they're not going to attract any valence electrons to them in order to fill them, okay? So if you think too about oxidation, we talked about the different oxidation numbers. Remember, this is a +1, +2, +3. This is +3 minus 4, plus or minus 4. And then we go into the positives, so +3, +2, +1. Okay, all of these that have high electronegativity, these are negative, -3, sorry, -2 and -1. All of these that have the high electronegativity, they all have the oxidations that are negative because they are more likely, or the most likely, to gain electrons in order to fill their outer shell. Okay, so that's why we see higher electronegativity on this end of the period.